Hello friends, welcome to my physics class. Today we will discuss the potential energy of a spring. So, as we know, spring are of two types, that is one helical and spiral. Assume that the spring are massless. So what happened? What is the meaning of massless? Massless means restoring elastic force in a spring is same everywhere. That means that everywhere the spring is having same restoring force. So to produce compression or extension in a spring, two equal and opposite forces are applied on the spring. So in equilibrium, the restoring force equal to the applied force. So usually what we have done here, that we assume that spring is massless and also it is on the frictionless surface. So in order to produce the compression in the spring, two equal and opposite forces are applied on the string. When we compress it, it will try to regain its original position. So what is its definition? The definition is potential energy of a spring is the energy associated with the state of compression or expansion of a elastic spring. If this is a spring, if we apply force on it, so it will reach in this position, then again it will restore its particular position. Why? Because of the reason is restoring force. Restoring force is the main reason. So if you look at here, we have taken a spring here. Its name is OA of negligible mass. It has no mass. It is connected and O of the spring is fixed. We have made this thing as a fixed. A body is attached to the free end of A. This is the body, we have attached it. Let the spring be oriented across the x-axis, so it will move only in the direction of x-axis. We have fixed it. So mass lie on a frictionless horizontal table. So this is a frictionless horizontal table. So what we do here, when we compress it, when we compress the spring, it tends to recover its original length. What is the reason? Force trying to bring spring back to the original configuration is known as the restoring force. So according to Hooke's law, for a small stretch or compression, springs obey Hooke's law for a spring, that is restoring force is equal to stretch or compression, so that minus F is directly proportional to X. So here F is negative, so that means it is a restoring force. It is when we have applied the original force, then to counter that it regains its original path, so it is minus F. So we remove the directly proportional sign, so it means minus F equal to Ks, where K is called as a spring constant. So if the compression is more will be the restoring force. If you look at the spring constant, K is called as spring constant, it is minus F by X. So we know force is equal to mass into acceleration. What is acceleration? Is LT minus 2 upon X is length. So it is M1 L0 and T minus 2. So what we observe from here, greater is the force constant of a spring, smaller will be the stretch or compression of the spring for a given force. Another thing we have learned, spring with a greater force constant is said to be stiffer. So spring with smaller force constant is soft. So thank you very much.